Hey class, this is lesson 65. This is, I think, hopefully my last recorded video. Hopefully from now on we'll be in person. This lesson is on proportions with mixed numbers and similar triangles. First, I want to do a review of the perimeter and area problem from yesterday with these semicircles here. So I'm going to work one of these problems and we'll move on to today's lesson. So yesterday we went over shapes that look like this. They included these semicircles here, and you have to find out the distance along that arc to find the perimeter, and then you need to find the area of those semicircles to find the area of the whole figure. So let's start with perimeter. When you see a shape like this and they ask you to solve for the perimeter, first they're going to give you some measurements and you have to figure out the others. Okay, we've done this a few times now. If you see the bottom side, well, first you see that there's 3 areas here. It's a rectangle, a semicircle, first semicircle, and then another semicircle. I'll label them 1, 2, 3. To find the perimeter, we need to find the lengths of these other 2 sides here, and then the arcs. The arcs, as you recall, that's the distance around the outside of the semicircle. If the bottom side is 20, if this radius is 6, we know that this is 6, and this is 6, and this is 6, because from the center out to any edge of a circle is a radius, and that's 6. So this is going to be 6. Likewise, this is going to be 6. I can come over here to my other semicircle and do the same thing. If this is 7, this is 7, this is 7, and this is 7. All right, so now we know the length of this side here, and that will tell us this side over here. If the bottom is 20, and if this portion here is 12, right there, this must be 8. All right, now I have all my straight sides. Let's start calculating perimeter. Let me start with the side that's 20 and go clockwise. So I have 20 plus 14 plus 8. Then I'm going to need the distance around arc number 1 and arc number 2, and that will give me my total. If you recall, the formula for the circumference of a circle, do you remember what that was? You might as well memorize it now, is pi d, so that the distance around half of that, or half the circumference, is going to be obviously pi d over 2. Okay, and so that will be the distance around that first arc, pi d over 2. Same thing for the second arc, pi d over 2. Let's calculate that. Okay, so we have pi, let's finish this imaginary circle here. I know it looks like an egg, but it's a circle. If the radius is 6, the diameter is 12. Okay, and 12 divided by 2 is 6. That's going to give me 6 pi. Let's do my second one. All right, this is pi d over 2, and that is pi. All right, let's finish our imaginary circle here. If the radius is 7, it's the radius of a circle whose diameter then is 14. We're going to double that radius to 14. 14 divided by 2 is 7, and that gives me 7 pi for my second arc. All right, if we add that up, 20 plus 14 plus 8 is 42. And then 6 pi and 7 pi gives me 13 pi. Okay, don't try to add your constants, that is your numbers, your standalone numbers here, with your pi. Those cannot be added together. They have to be separate. If you choose to multiply 13 by the value of pi, which is 3.14, you can do that. And that gives you 9.42. Now it's just a standalone number, and you can add those together. What is that? I think that's 51.42. Let's say that's centimeters, all right? You may leave your answer in this form, or you can calculate pi and put it in this form. Either way is fine with me. All right, let's clean this up a little bit. Okay, do you remember the formula for the area of a circle? We're going to need that here. That is pi r squared. So the area of a semicircle is pi r squared divided by 2. Let's calculate our 3 different areas here and add them up for our total square area. First, I have my area 1. That would be 14 times 20. I'm going to do this quickly in my head. 14 times 2 is 28. I'll add my 0. That's 280 centimeters squared. Area number 2 is my first semicircle there. Now that's going to be pi r squared divided by 2. And the radius we see is 6. It's going to be pi. 6 times 6 is 36. Remember, 6 squared is 6 times 6, not 6 times 2. We divide that by 2. 36 divided by 2 is 18, and we get 18 pi. So we have 18 pi centimeters squared. Our third area there, our third area is just another semicircle. Again, that's pi r squared divided by 2. Our r is 7, our radius is 7. 7 times 7 is 49, and then we divide that by 2. 49 divided by 2 is 24.5. Oops, oh, I forgot my pi. Don't want to forget the pi. Now we can simply add those areas up. And once again, you have 280. You can add your pi's together, but you cannot add your standalone number 280 with your numbers combined with pi. What is 18 and 24.5? Let's see, that's 42.5 pi centimeters squared. Let's see, 280 plus 42.5 pi centimeters squared. That's leaving it in terms of pi. If you want to go ahead and multiply 42.5 times 3.14, get a number for that and add that to 280, you are welcome to do that. Or you are also free to leave it in terms of pi, like I said. Right, I wanted to review this because I think you're going to get a few little questions on that next week. But all right, let's get into today's lesson. Get my eraser going here. Alrighty. First concept is proportions with mixed numbers. This is basically exactly what we've already learned with proportions. As you recall, a proportion is something like this. 2/3 equals 4 over x. All right, we have two fractions that are equal to each other. They are proportional. If I were to have said 2/3 equals 4 over 6, that's a proportion. When there's a variable in there, that's a conditional proportion, and we need to solve for x. And the way that you do that is to cross multiply. I like to start with the multiplication that includes the variable, so that's 2x, and put that on the left, and set that equal to the multiplication of the other two numbers, 3 times 4. All right, and solving for x, we divide both sides by 2. Those cancel, and x equals 6. That's solving for a simple conditional proportion. Then we moved into proportions with fractions. And so this is just a continuation of that idea, but instead of fractions, we are going to use mixed numbers. All right, let me write a problem here for you. I'm going to write a conditional proportion with mixed numbers. actually mixed numbers and fractions. Every time they teach you something, they have to throw in the same type of problem with mixed numbers. By now, you should be pretty good at turning a mixed number into an improper fraction. So that's the only step you have to add here. You want to turn your mixed numbers into improper fractions and then go ahead and do the same thing you would do with any cross multiplication. All right, so let's convert this. 3 1/2. 3 times 2 is 6, plus 1 is 7, over my same denominator, over 3/5 equals x over 4 times 7 is 28, plus 2 is 30, over my same denominator, 7. Now I can just go ahead and cross multiply. Once again, I want to put my x on the left-hand side, so I'll start with that. 3/5 x equals 7/2 times 30 over 7. Remember that we can cancel to make our multiplication easier here. I'm going to cancel those. I'm going to cancel those 7s. And what am I left with? I'm just left with my 15 on top. So I have 3/5 x equals, I'm going to leave it over 1 until I'm done with the problem. Now to get x all by itself on the left, I need to multiply by the reciprocal of 3/5, which is 5/3. Reciprocal just means to flip the fraction. Another word for it is the inverse. Okay? How did I get it? Red. And I have to do the same thing to the other side. Always have to do to one side what I've done to the other. All right, these cancel, leaving x all by itself. On the other side, let's see what I can cancel. 15 becomes 5 times 3. Cancel those 3's. I am left with 25 in the numerator and 1 in the denominator. And that is just x equals 25. Anything over 1 is just itself. So that's all you have to do here. Cross multiplication is a very simple concept. All they want you to do here is when you approach your problem here, make your mixed numbers into improper fractions first, then go ahead and cross multiply. All right, and this lesson also contains one other concept, similar triangles. All right, this is where my artist skills, or lack thereof, come into play. I'm going to draw. Helps if I have a color there. All right. Let's see what I can do. And I'm going to draw a larger one. I'm going to fix this just a little. These are supposed to look identical except for their size. So they're supposed to be proportional. All right. I'm going to label these sides 2, 4, and 5. And the sides of the other as 3, x, and y. Okay, if we look at these, every triangle, of course, has 3 angles. And if these angles, this is how they mark them, if they are the exact same angles in both triangles, regardless of the size of the triangle, if the size of the triangle is different but the angles are the same, they are called similar triangles. Okay, different size but same angles. They're called similar. And their sides are going to be proportional. So if you kind of see, you know, this side is the same as this side, and this side here, these sides are the same. They're going to be proportional to one another. Okay. If you look at the colors that I've drawn, we can say that 2 is proportional to 3, and 4 is proportional to, oh, we have a variable, okay. We can say that 5 is also proportional to y. Those are all going to be proportional to each other, okay, because they're similar triangles. Think about if you've ever done model cars, okay. Have you ever built like a cool model car? Probably looked way cooler than this, okay. And they would say this is to scale. So it'd be like the identical replica of an actual real car. It just was tinier. But they're proportional in all their dimensions. So it's the same thing with a similar triangle. So what you can do now is if you have two similar triangles and they will have identical angles, and you have one triangle with missing lengths, like here in my right triangle, X and Y, we're missing those. We can use a proportion to solve for those. So let's take 2/3 and set it equal to 4 over X. 2, we'll say 2 is to 3 as 4 is to X. Now I can cross multiply. All right, and starting with my X on the left, I'll set that equal to 12. Divide both sides by 2. Well, this looks similar to my example, doesn't it? At last, in when I was doing the last example, divide these 2, cancel the 2's, X equals 6. So we have our first side, 6. In the same way, I can take 2/3 and I can set that equal to 5 over Y. Let's cross multiply to solve for Y. Let's keep my variable on the left and set that equal to 5 times 3. And we find that Y is 7.5. All right, and that's all that you have to do. Is similar triangles fit into this lesson because we use the idea of proportions and we use cross multiplication to solve for those missing sides. So your main task is to look at those similar triangles and figure out which side is to which side. Right? Seeing that this side is similar to this side, right? And this side is similar to this side. And then obviously last, this side is similar to this side. Once you do that, you can set up your proportion. You can cross multiply and solve for those missing sides. All right. Hope that was clear. I think I won't do another problem, and I'll be seeing you on Tuesday with any questions. All right, signing off.